Hey everyone, this is Udayitya from TechSprout with another session covering the data engineering question answer. And in today's topic, we're going to discuss the differences between various Spark APIs such as RDD, DataFrame, and Dataset. So before going into the discussion, a bit about myself. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. So before starting off the discussion between the differences, let me just give you an overview of what these APIs are and how they work basically. So if I try to process any file or data that is lying under the Hadoop cluster or any cloud storage for that matter, so the first thing that comes to our mind is when we read the data, how would it look like? If I try to see the result, how the data kind of itself present itself to me. Okay, so that's where this API comes in. When you try to see the data, you'll understand the key differences between the RDD data frame and the dataset API. So let me go over these APIs one by one and try to discuss. And obviously, we're gonna have a live example of these two, the RDD and the data frame. For dataset, it's not possible since we're gonna be using the PySpark API, and in PySpark, dataset is not supported. Fine. So let's talk about the Spark RDD. So this has been the oldest API. It's been there since the inception of Apache Spark, and before Spark 1.6 or something like that, only the RDD API was there. No other, I mean, the data frame and dataset weren't available at that point of time. So processing any data at that point of time, it had to be done using this API only. So it's a low-level abstraction. RDD is a distributed collection of objects and operations are performed on these objects directly. So how the RDD looks like is basically if you ever work with any data structure, so to speak. So if I talk about Python, right? In Python we have list, we have arrays, and so it's something like set and tuple. So RDD is kind of like one of those data structures. Okay, when you try to see the data, it will look like a tuple of different records. And when I say records, it's basically nothing but the lines from the file that I read in. So if there's a text file or there's a CSV file, so each and every line will be a record, and each and every record will present itself as a tuple of different fields or attributes. So basically, it's not presenting itself in a columnar format or tabular format where we can put a select query, or we can just give the column name or attributes and simply fetch the results out of it. Second thing, it's immutable and fault tolerant. RDDs are immutable and can recover from node failures using lineage information. So immutability means that once it is created, we cannot change it. So it's no surprise. I mean, in Hadoop data lake, everything is kind of immutable, right? You cannot edit or update any record in Hive. You cannot modify any file in the Hadoop system. Only thing you can do is you can simply read the file. You can do some processing over it, but you cannot modify the data underlying it. You can simply just create new data out of it and put it into another storage. So that's how the whole Hadoop ecosystem or the data lake concepts work on. Now, there's no difference in Spark RDD or Apache Spark, so to speak. So it is immutable, but it's also fault tolerant. It's again one of the key features of the Hadoop data lake, right? If any node goes down, there are other nodes to take care of. Similarly, there is a property called the lineage, which kind of works the similar way, which means that since, as I told you, in the Spark architecture, right, there would be a driver program that will be run by the application master, and the driver itself will spawn different workers in different other nodes, which are like the slave architectures for the master one, that is the driver. So these workers that are running in different nodes, if one of them goes down, obviously there are other nodes where the same task is being executed by other workers, and that's how this Apache Spark RDD API is fault tolerant in retrieving the result from the other nodes or from the other workers. So this is known as the lineage. Thirdly, and it's kind of like the most important factor for Spark RDD, that it doesn't have any predefined schema. RDDs don't have any built-in schema information, and that is the reason it's so different from the data frame. You'll get to know that how data frame is easily retrievable, or anyone can easily fetch the attributes out of a data frame. But when it comes to RDD, there is no such way we can simply parse the data or we can have a tabular visualization. And if I talk about the functional APIs, it uses functional programming constructs such as the map, filter, reduce for transformation and actions. Now, I'll come to the transformations and actions in later one of the sessions, and I'll briefly explain how they work and how they are different from each other. But for the moment, just know that it has the functional APIs that is being worked upon any raw programming language such as Scala or Python. In Python and Scala, we do have these aggregators that are working on top of the data structure of the same programming language. Like if I talk about Python, Python has the functions such as map, filter, reduce, etc. Similarly, Scala has the same functions. And these functions, they work upon the Spark RDD in a similar way. Okay, so it's basically we are dealing with raw data structures when we talk about Spark RDD, but the only difference is in raw programming languages such as Python or Scala, we are running them in single thread. There is no multi-processing by default. There is no like multi-machine kind of a architecture is there. But when it comes to Spark, obviously it runs on Hadoop. It runs on distributed parallel processing engine. So the whole processing will be done parallelly and the distributed ecosystem. Thus, we are achieving the faster or optimized processing of each and every file that we read. Right. So with this, there are some advantages and disadvantages. If I go through the advantages first, it has a fine-grained control over data processing, which means I can parse and customize the data the way I want. Simply, it doesn't have a predefined schema. I can create my own customized schema, or so say I can create my own customized array or data structure the way I want. Had it been data frame, there's already like predefined columns and data types, right? But over here, it's not there, so that's why I can parse it. I can customizely parse the data the way I want. So that's the independence that I got in Spark RDD. That's not available in Spark Data Frame. It's suitable for complex custom low-level transformations. Obviously, as I said, since it has like a data structure level API constructs such as the map, filter, reduce, so I can easily apply these functions into any rows, into any records, right? Whereas in data frame operations, there are some PySpark SQL functions or Spark SQL functions, they can be applied and not these ones. It also provides strong fault tolerance via lineage. So ultimately, RDD has the lineage property, but so when I'll be using data frame, that means the data frame doesn't have lineage? No, that's not correct, because ultimately all the APIs will get broken down to RDD. It's like the granular unit stuff, or the how should I put it? Everything at the end comes to the Spark RDD before the process. Even if I write code using the DataFrame API, under the hood, it will get broken down to RDDs, and then it will start working. So basically, whatever the code that I'm writing on a high level, only that part will change. But internally, the RDDs will get processed, or the RDDs will get executed. So that is why the RDD has the lineage property, which it carries even when we are using the data frame operation. And obviously, there are a lot of disadvantages. One is it's not optimized. I mean, operations are not automatically optimized. It requires manual optimization for performance when we deal with customized, customized EPR or customized parsing the data. We have to keep in mind what would be the best way to have the processing totally optimized and without taking a less amount of time. So Spark RDD will only consider the code, or will only consider the flow of the processing of the task the way you define. If you're writing the code, it's totally up to you, or it's your responsibility to make it optimized. The Spark won't do it automatically. Okay, so this thing changes when we come to DataFrame API, and why this changes, how it changes, obviously I'll be discussing in the second slide. It's verbose and harder to use harder to use compared to high level abstractions. And yes, since the data will be presented to us as part of data structures, or they will be they will be shown to will be they will be shown to us like data structure of each and every row. This function level APIs that we have to the function level APIs that we have to apply, such as the map, filter, reduce. So we have to be very considerate while using those. We have to have a very good programmatical understanding of how this functional APIs we can make use and obviously pass the data and make it optimized as well. So if I have, say, rows of different tuples, in that case, if I want to apply some map or filter or flat map, for that matter, in that case, I have to know the exact sequence, the exact way that I can apply those functions, and obviously this will be optimized in a way that my code is less boilerplate, having less boilerplate code, and at the same time, it's running in the most enhanced way. So these are the reasons Spark RDD that became obsolete with the Spark 2.x. Later on, mostly everywhere almost the DataFrame API is being used. And when I'll come to the live example, you'll get to know why the RDD, instead of RDD, why DataFrame is being widely used now. Okay, so now the DataFrame. So this is the newer one and obviously the widely used one. It's a high-level abstraction similar to a table in relation database or a pandas data frame in Python. So if you have worked with pandas data frame in Python, you know that it already provides you the data in a tabular format. So it's very easier for you to analyze the data or to fetch some of the attributes of the data. Similarly, if you have worked with relation database such as Oracle, MySQL, just using simple SQL queries, you can get the data, you can showcase the data. So DataFrame API is kind of like same. You can have SQL operation, SQL queries over there, and also you can have the field level API, such as you will get the schema, you will get the attributes, the columns, and everything. You can easily just select them and showcase in your console. It is schema based, organized into named columns with data types. Like I said, the way we see the data in the relation database, it's much like that. Everything will have a predefined schema and will be presented to you in a tabular format. Okay, third point is very crucial. Optimized execution uses Catalyst Optimizer for query optimization. Now, how the Catalyst Optimizer works and what it is, probably I'll discuss in one of the later sessions. But for the moment, just know this, as I mentioned in the previous slide, right? The RDD has the lineage property, and everything gets broken down to RDD only. Even if you write a code using the DataFrame API, there are some steps after which it will get converted to RDD before processing. But so the difference between that and this is that whenever we write the code in DataFrame, this time Spark will automatically uses the best or optimized plan and then converts to RDD and then does the processing. Whereas for Spark RDD API, when we were writing the code using the RDD API, in that case, it was totally up to us, to use the best optimized plan. And if you're not knowledgeable enough how the RDD works and how we can use how most proficient way we can use the data structure, it would be very difficult for us to make our code optimized to run it faster. Whereas for this one, the Catalyst Optimizer do the things under the hood, so it's not necessary for us, to make it optimized. It's up to the Apache Spark, and it will do it automatically. Fourth point, which I just discussed, it supports SQL, provides an interface for writing SQL queries directly. If I'm using DataFrame API, I can simply just do a spark.sql and put my SQL query over there, and simply the data will be processed accordingly. Now let's talk about the advantages and disadvantages. So it's a high-level API, simplified development, obviously writing the code, which is much faster over here. Catalyst Optimizer improves the query execution performance, as I just discussed. Under the hood, Apache Spark will automatically find out the best optimized cost plan, and accordingly the RDs will be generated based upon that optimized logic plan. Third one is the integration with structured data sources. Now DataFrame API has been used widely when we are taking the structured as well as the unstructured data while reading it from the Hadoop cluster. Now, these structured data sources such as the we can easily read the data. In fact, even for some semi-structured data like XML, this data frame API can handle. So that's one more plus point. Even in case of RDD, it would be next to impossible to read the semi-structured data into Spark RDD and then do the operation. So these are the advantages. And if I talk about the disadvantages, it has a limited type safety compared to datasets. Operations might fail at time due to schema mismatches. Yes. So first one, I haven't gone to datasets. So if I talk about datasets, so there is something called type safety, which is not over here in the data frame. The reason I'll explain in the next slide. But if I talk about the second disadvantage is that operations might fail at runtime. Yes, that is true. I mean, in our real world project, we have seen many jobs failing because the schema is not matching with the file or with the Hive table. So that's one thing that we need to take care of every time we write a code in the Spark data frame. Now coming to the last one, which is available only in Scala and Java. So that is the Spark dataset. So it's kind of like a hybrid model that comes in between the RDD and DataFrame. It provides the typed object-oriented functionality of RDDs and the optimized execution engine of DataFrames. Okay, so when I was discussing Spark RDD, right, I told that we can use the functional API. I mean, those are the only ways we can pass the data, we can process the data, such as the map, filter, flat map, the ones which are mostly used in the raw programming languages such as Python, Scala. But in case of DataFrame, we don't have the option to use those functional APIs. We can only use the SQL functions such as select, filter, group by, order by, and whatnot. But if I want to use those functional APIs and also I want the advantage of the DataFrame API, that is the optimized execution engine using the Catalyst optimizer, in that case, I mean, the dataset API kind of like combines the both and gives you this new whole architecture. So that's where dataset kind of like excels. But still, there are some other disadvantages which I'll be talking about. But yeah, the second point is type safe API. Compile time safety ensures fewer runtime errors. Now, in the DataFrame API in the previous slide, you did hear about the disadvantage. One of the disadvantages is that it is not type safe, which means that whenever I'm trying to select or do any processing on any column, so in that case, the column name that I provide, Spark doesn't check in the compile time, meaning the Spark compilation will succeed even if the column name is wrong. Okay. Whereas if I use the dataset API, in that case, at the time of compilation, it will check whether the schema or the metadata information that I'm providing in my code is correct or not. So that is the type safety. In the compile time only, it will be caught that I'm not using the proper column name or something like that. Third one is the schema enforcement. It uses encoders to serialize objects, ensuring schema consistency. So in case of DataFrame API, we had to define the schema over there with the data types. But in case of dataset, we don't have to schema, but we can create a class or a case class for Scala, and we can simply use that object, or you can use an instance of that object as the schema. So these are something very specific to Scala. So I'm not going to discuss the technical nitty-gritties of how a case class works and how can you convert that to schema. And these are the reasons why the dataset API is not supported in Python, but it's only there in Scala and Java. Okay, but we must know about the differences between the DataFrame dataset and the RDD, as in the interviews they quite often ask the differences between these three APIs. Now there are some advantages using the dataset API. It's the best of both worlds. It combines the benefits of RDD, type safety, object-oriented API, and the DataFrame's optimized execution. So if someone who's a developer who wants to use the functional API and also want to take the benefit of the optimized execution, then he can use the dataset API. It's more efficient than RDDs due to query optimization, And that is very true because it has the catalyst optimizer, just like the DataFrame API. It is safer than DataFrames because of the compile time check. So if someone wants to have its code like totally bulletproof and he doesn't want to even negotiate in terms of defining proper column names, in that case, Dataset API is the way to go. I mean, that can only check the compile time, that can only check the metadata information errors at the compile time rather than the runtime. But still, there are some disadvantages. More verbose compared to data frames, requires extra effort to define schemas for custom objects. Now, for data frame APIs, if we read a Parquet file, the inbuilt schema will work upon it. But if I want to use the dataset, obviously, even for a Parquet API, for a Parquet file, this schema I have to define in terms of a case class if I'm using the Spark Scala. So you can understand if there are like 100 columns inside the Parquet file, instead of like inferring the schema that is already there in built, I have to define a case class with 100 of 100 attributes or 100 fields. So it's gonna take some time, it's gonna take some effort. Okay, so that is the reason in all the cases it's not recommended to use the Spark dataset. It's only where you want to use the type safety of the columns, as well as if there are any special cases or scenarios where you want to use the RDD functional API, such as the map, filter, flat map, then only you can go for the dataset. All right, now it's time for some example. So I'm gonna head over to my Databricks cluster. So this is just a Databricks community edition, and it's totally free. If you want to run your Spark code or some Spark queries in your Databricks account, you can simply create a Databricks account using your Google or Gmail ID, and then what you have to do is you just have to create a cluster. So you have to create a cluster, and then only you can run your Spark code. Without any cluster, you won't be able to run any sort of PySpark or Spark Scala code. All right, so I'm going to add a cluster over here. So I'm gonna give the name my cluster, and this is by default the latest one which it takes. So I'm gonna keep it as 3.3. Let me use the 3.4. It's more updated version. And then what this will do, it will automatically create a cluster and attach to this notebook. So inside this notebook, I'm going to be running my query. So let me just create and attach. So currently it's starting. I'm going to have to wait till it starts. Otherwise my queries won't be able to run. So in the meantime, I have a file called fakefriends.csv, which I have stored in the DBFS. So how do we store a file in DBFS and everything, I will cover in the later sessions. For the moment, just know that there is a file, and first I'm gonna try to use the RDD API to read this file and show you how the data presents itself when I try to see it in the console. Okay, so this snippet of code is going to just create the RDD. So first of all, this Spark is a Spark session. So whenever I use the Databricks or whenever I create a cluster, so by default Spark session is created and provided to me with this name, Spark. Okay, and I will go into the coding part later session. I mean, there would be like a full end-to-end from scratch Spark code where I will show you how we can create a Spark session in the name of Spark. But if we are using any notebook like Databricks or even the Spark console, in that case, the Spark the Spark session is already created and presented to us, and we can use it. Okay. So from the Spark session, we're gonna call the Spark context. So Spark context is an API that we only need whenever we are trying to deal with the RDDs, because whenever we want to read the data from data using the DataFrame API, in that case, Spark context is not required. Only the Spark session is enough to read the data from our Hadoop file system. Well, in this case, it's not Hadoop, but the database file system. Okay, so I'm still waiting for my cluster to be up and running. It's showing starting. Let me just run this one and check if it's up and running. All right, now the cluster is ready. I think the RDD is already created. So let me just try to showcase the record of the first 10 lines. So only the first 10 records I want to see. So to do that, I'm going to be using the take function and put the number that I want to see. So if I run this one, to see how the data looks. Okay, so I have this data inside my CSV and it doesn't have any header. It looks like it starts from 0, 1, 2, 3, 4. The name, each and every data has been presented in a list. Okay, there is no such schema or there you don't see any tabular formatted way it has been presented. It's just a list with comma separated lines and that's it. So if you try to do any select column or any options, that is not permitted over here. You have to do customized parsing only, and after that you can just fetch the fields for each and every record. Right. So similar. So this is how an RDD looks like. Now I will try to create another cell just below and read the same file using the DataFrame API. So see how different it looks. So as I said, right, to read the data using the DataFrame API, I don't need the Spark context. I only need the Spark session that is already available to me in the name of Spark. So spark.read. This is a CSV file, so I'm going to put CSV over here, and I will copy the same file path from here. Let me put it. And I will put a show over here. Let's see how the data looks like over here. Okay, now you see the difference, right? So now it has been, so why is it not showing the, yeah. So now you can see that it is present in a tabular format. Now there is a row column structure by which you can understand how the data is separated from each other, like how each and every record are distinct. The only caveat over here is that I don't have a predefined schema. I mean, I don't have the column names. So you can see it doesn't have any header, right? The CSV file doesn't have any header. So by default, it has given like underscore C0, C1, C2, C3. These are the column names. So what if I want to change this? Okay, if I don't want this one, but I want some like meaningful column name, in that case, I'm gonna have to use the toDF method. And over here I have to put the column names one by one. So first one is the serial number. Okay, second one is the name, which is Will John Luke. First one was 0123, that is the serial number. Now second one is name. Third one is this column 3326, so that is the age. And the last one, which is the 385 221, so that is going to be the number of friends. So if you try to map the same column names with the existing one, so C0 is basically serial number, C1 is name, C2 is age, and C3 is number of friends. Okay, so by default, if I call in the show, you see that there are like, oops, yeah, there are 20 records that are coming in, right? So I don't need these many. I mean, only 5 will be fine for me. So how can I customize that? So over here inside this show method, if you just put the number of records that you want to see, then it will only fetch those many records. Okay, so now you can see how formatted my data looks like. Like it has certain aspects, or it has the certain field names that I require. So this is the serial number, the other one's the name, age, and now putting the number 5, I can only see that only the top 5 rows have been reflected over here. So now you understand, right? Just see the difference between the two APIs. So this is the RDD one, and this is the DataFrame one. And if I try to do some select query, if I try to do some SQL query, or try to do some filter, it's much easier for us because the field names are already provided. Okay, so I can put in any operation just by using the field name. But over here, the field names are not provided. I have to first get the field names by parsing each and every record. After getting the field names, then only I can do the processing. So that is the basic differences between these three APIs and how they differ from each other. So that's all from this session. If you need more guidance and you want to know more about Apache Spark Hive, then you can simply reach out to us, reach out to TechSpark. We cover all the necessary tools in our data engineering course, such as Spark, Hadoop, Hive, AWS with hands-on coding and real-world projects.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.